Hey, today we're going to begin our unit on databases, which is Access, called Access in Microsoft Office. And you can see today's going to be part 1, and then the hands-on lessons begin with part 2, and then all the way through part 5. So what is a database? Every time you use Google to find something, chances are the search results you see on screen were retrieved from a database. A database is a collection of information that is stored on a computer in an organized format so the information can be easily accessed, managed, and updated. Think of a database like an electronic filing cabinet. Although you may not realize it, you probably access multiple databases every day. The contacts in your cell phone, using a map app, or accessing iTunes to download a song. All the information that you're accessing is stored using a database management system. Just about every business and organization, large and small alike, use databases to manage and store information. So why should you learn about databases? For any type of business organization, databases are the primary tool for storing, managing, and analyzing information. Without databases, we wouldn't have search engines, phone directories, or even the ability to use a website to order a pizza. Whether serving the needs of large internet search engines like Google or simply being used by your school to track students, classes, and grades, databases play a vital role in today's high-tech world. The amount of data that needs to be stored and managed is only increasing. Given the explosive growth of everything from smartphones to tablets to wearable fitness trackers and GPS tracking devices, more and more data is being collected and shared. Understanding databases and the information and the data data they provide is an essential workplace skill to have. The structure of a database. A database is structured by storing and organizing interrelated information into one or more tables. Similar in format to a spreadsheet, a table uses columns and rows to store data in a cell or the intersection of a column and a row. Tables contain a series of records. Each record contains data segments called fields. For example, a record for a business's customer might contain fields such as first name, last name, street address, city, state, and zip code. Each field within a database is required to have a data type. A data type is a term used to determine what format each field in the database structure is defined as. While there are a variety of data type format options, some of the most common are listed in the following table. These are the ones you'll use most often: long and short text, number, where you want to format the number in a variety of different ways, but basically it's a number you're going to use in a calculation. Not like a zip code or a phone number. That would be considered long and short text because you would never use that in a calculation. Yes and no is used to determine if the data in that field has a yes or no answer. Date and time, a whole bunch of different formats for that. And object. The object data type is used for formatting fields that contain data that cannot be entered by a keyboard, such as an image or sound file. To illustrate how data types are utilized in a database, let's take a look below at how a database record would be constructed to collect and organize data required for students in high school. So these would be all the field names, and these are the data types that they would be. Well, student ID number, I guess they're going to use it as a number. That's fine. First, last, zip is a text though, okay, because you won't use a zip code in a calculation. Phone number they use as a number. You can see how they're all right here, student picture, and are they a member of a club, yes or no. So database tools. We all use different tools to find the information we want, from search engines to apps. Today's technology allows us to find information quickly by using multiple sources. Behind all these tools are databases that must be accurate, reliable, and managed. Database management systems. It's the tool that manages all of that information is known as a database management system. Used by just about every business and organization, a database management system is a computer software application that enables users and applications to interact with a database to capture, store, retrieve, and analyze data. To be frontrunners in their respective industries, businesses have come to rely on database management systems as a primary technology tool. A good example of a technology that utilizes the power of a database management system is a mobile phone. The software on your phone accesses the contacts database so that data records can be displayed, utilized, edited, or deleted. Database management system packages generally provide an interface to view and change the design of the database, create queries, and develop reports. To further explain what a database management system is, let's take a look at a real-world example of how Apple's iTunes uses a database management system. In order for phones or songs to be viewed on screen and played for users, the iTunes application needs to access one or more databases. Back at Apple, the iTunes database is managed by a multitude of technical staff using a dedicated database management system. Some employees use the database application to add new records, in other words, new artists and their songs. Others manage these records by inputting more data, such as a song's genre. So here's the database into the database management system and out to apps. So determining database software. There are two categories of database software. Desktop database software is typically utilized by home users and small businesses. Examples include Microsoft Access, like what you're going to learn in here, My Database, and FileMaker Pro. Enterprise level database software is used by large companies and organizations that need to manage and share information across many platforms among a large number of users and across distant geographical locations, even worldwide. Examples include Oracle, Microsoft SQL Server, and IBM DB2. Selecting database software. In order to determine what database software and system to use, businesses must define what their data requirements are. As a starting point, all businesses need to answer the following questions. What type of information needs to be collected? Will the data need to be accessed and shared by multiple users, and if so, by how many? How many users can the database system accommodate at one time? Will customers need to access the data? Will data need to be served on a website? If so, does the database software support that technology? And can the database software integrate with other business applications? So, working with Access. To complete these hands-on lessons, you'll need to use Microsoft Access, a database management system application produced by Microsoft. Microsoft Access is one of the most popular database applications, commonly used by both businesses and individuals. Microsoft Access enables users to create custom databases and contains a variety of tools to manage their data. Like most database management systems, Microsoft Access comes equipped with a variety of features to access, format, and retrieve information, including creating visual forms for easy data entry, searching and browsing abilities, connecting to websites and external applications, queries, generating reports, sorting data, filtering data, importing and exporting data. So database relationships between tables. A database can be made up of one or many tables. When a database contains more than one table, often the tables will have identical fields, forming a table relationship. A relationship works by matching data in key columns, usually columns with the same name in both tables. The database relationships keep users from redundant data entry, which means repeating the same entry. To demonstrate the concept of table relationships, read the following scenario. Libraries use databases to store information about books and publishers. Let's say the local library creates a database containing just one table called book titles, which includes fields such as book title, date of publication, publisher's name, and publisher's phone number. In this one table database, a redundancy would occur. Since many books have the same publisher, the publisher's name and phone number would need to be entered multiple times. A better solution would be for the library to create a separate table called Publisher Contact Information, which would include the publisher's name, address, city, state, zip code, as well as the phone number. An identical field, the publisher's name, for example, shared by both the tables, the book titles and the publisher contact information, would create a table relationship. This relationship would make it unnecessary to enter the publisher's phone number in the book titles table. Relationships between databases. A company may have one or many databases as their data management systems. When there is more than one database with a data management system, they typically have pieces of data that are shared or related. Databases that are related to each other are referred to as relational databases. Browsing a website that sells technology equipment, for instance, may have a catalog database so that users can search for products and a separate technical support database so that users can search for answers to technical support questions about a specific product. The website itself is not the database. However, as users are browsing and searching for products, the website is communicating with each database. While the two databases are separate, they have a relationship to each other, in this case, the product field. Since a relational database is a collection of data organized as a set of related tables, its data can be accessed or reassembled in various ways without having to reorganize the database tables themselves. To illustrate relational databases, let's look at a popular college information website. College.org or collegeboard.org is used by millions of potential college applicants to help find information about colleges. For example, let's say a high school student wanted to find which college offers physical therapy as a major and are located in warm climates. To find the answer, collegeboard.com first would look in its college database for institutions that offer physical therapy. Next, it would look in a geographical location database for a location with a warm climate. Then it would reference this location with the locations of its physical therapy colleges. The records of colleges with warm climate locations would be returned as the answer. Analyzing and retrieving data. Information isn't very useful if we don't do anything with it. Databases aren't just a great tool for sorting information. Information isn't very useful if we don't do anything with it. Databases aren't just a great tool for storing information, they also make information useful. The process of studying information to make it useful is known as data analysis. The process of accessing data is known as data retrieval. Database software applications provide commands that allow data to be filtered and retrieved. While it may sound like a technical term only used by business people, we all analyze data, asking the right questions to find the right answers. Analyzing and retrieving data is essentially asking questions. In fact, a request for a specific answer or list of records from a database is called a query. For reading the sports statistic page to tracking the progress of a diet, looking at data helps us make decisions on the answers to questions we ask. How much weight have I lost this month? Do I need to adjust my diet? How are my players on my fantasy football team performing? Should I trade some players to improve my team? To illustrate the importance of analyzing data, let's look at the following scenario. Choosing what college to attend is one of the biggest decisions many of you will make. A decision of this magnitude requires a lot of thought. To help you make a well-informed choice, you can count on data analysis for some help. Using real data, you need to get the answers to these and many other questions. What is the school population? What is the cost of tuition and room and board? What is the ratio of females to males? What are minimum GPA and SAT requirements? What are job placement percentages for graduating students? Where do you find the answers to these questions? A quick Google search might land you at a blog where you can read student reviews about the college you want to attend. But who are these students? What blog is it? With more research, you might find that the links you clicked on were to sites authored by those who possess minimal or no credentials. After sifting through additional information, you realize that data provided by sites like CAPEX.com and collegeboard.org offer more reliable data on all aspects of attending college. Your decision becomes clearer as you ask questions and find answers. In other words, as you do data analysis. So how businesses use data. Businesses regularly analyze data to help them make strategic decisions. For instance, let's say a national fast food company is considering launching a new type of cheeseburger infused with barbecue sauce. Before making any decisions, they advertise a new burger in only a handful of stores. After the testing phase is completed, the company would then analyze the sales data to decide whether or not to market the new burger in all of its locations. In a world flooded with information pouring in from the web, cell phones, and social media, we can't trust or believe everything we read or hear. When analyzing data, the same holds true. Imagine if you were asked to write a report titled, "The Top 10 Athletes of All Time." In the report, You decide to include statistics on each athlete. When your teacher passes out the graded report, you read the comment, "Many of the statistics you included were inaccurate." To avoid inaccurate or incomplete information, there are a series of simple principles to follow when conducting data analysis. Define your question. Before you begin the analysis, know the questions you're trying to answer and what you're trying to accomplish. What is it that you want the data or the information to tell you? Identify and know your sources. Where will you get the information from? Are the sources credible? Collect the data. With your questions and sources clearly defined, you can now gather all the data you will need to analyze. Analyze the data. Keep an unbiased opinion. Study the data from several different angles. And finally, interpret the results, summarize, and display the data. So data warehouses. How does the data we have today compare with the same set of data from this time last month or last year? So the concept of a data warehouse helps meet this need to compare different sources or periods of data. Today, businesses are able to collect and store massive amounts of data from multiple and often unconnected sources. However, databases that store this information may not always be optimized for processing large amounts of data and the other continuous retrieval of reports by employees, customers, and other information requests. The primary purpose of a database warehouse is to manage large amounts of stored data from multiple sources so it can be stored and accessed by a centralized system. A data warehouse essentially creates a copy of much of the data that is spread out across sources and over time, allows businesses easy access to their data to make informed decisions. The benefits of a data warehouse. A data warehouse helps an organization better see what data it is collecting as well as what data it should or should not be collecting. A data warehouse offers a centralized view of all data across a system, making it possible to see how clean or consistent the data is. Once the data is consistent, an organization can work off of one clean version of their data for better analysis of accurate information. With a data warehouse, snapshots can be taken of data over time, enabling an analysis of historical trends. This is known as data mining. Data mining in the business world, data mining can help businesses predict certain behaviors about their customers and products, including characteristics of typical customers, predictions about customer loyalty, purchasing patterns, items or services that are likely to be purchased at the same time, warning indicators of fraudulent purchases, best features for interactive business websites, identifying customers to target for specific ad campaigns. By being aware of these predictions, companies can use them to focus their marketing efforts, make decisions about when to introduce a product to customers, as well as decide to focus on a particular type of customer for certain types of products. To do this, a company needs to purchase and use data mining tools that generate this sort of predictive business information. Larger companies may decide to use dedicated data mining tools such as SAS, Enterprise Miner from SAS, or Oracle Advanced Analytics by Oracle. These tools are designed to analyze huge volumes of data and can be customized to work with unique needs of larger companies. These tools are also capable of performing more advanced data mining techniques that require a significant amount of data preparation and computing power. Smaller businesses can also use data mining tools that are now offered with desktop databases such as Microsoft Access or even a plugin for Microsoft Excel. Data mining does not use one single technique to produce predictive information. Some of the different techniques include clustering. It's used to group customer and or products into predefined clusters based on their characteristics. The behavioral customers and products can then be predicted based on what cluster they're in. Nearest neighborhood classification, the process of classifying business information based on how near or similar the information is to its neighbor. Defining the nearest neighbor is dependent on how a business views its customers and product relationships. Decision trees uses a series of questions to narrow down and segment the business information into a predictable result. And neural network, a highly accurate predictor of business behavior by using complex computer analysis. Databases are powerful tools for using information successfully. A database literally puts information at your fingertips. The electronic storage of data records makes it easy and fast to search, retrieve, and organize information in countless ways. Managing information with a database enables users to identify how information relates to other information in ways not possible with paper or spreadsheets. Databases save businesses time and money by making information easily accessible, efficiently analyzed, and used to make effective decisions. Understanding database basics and having a familiarity working with database tools are skills valued by businesses across every field. So if you encounter a skill or a feature that's not available in the software version you are using, use an equivalent feature or adjust your document accordingly. It's important to note that all of the database's lessons are written in a generic format, and in most cases, the skills required can be achieved using any version of Access. And so now you're going to do this. It's in Classroom.